So let's just start with the first task, which is part of the core routing chapter, and that's the IGP part. So we see that we're asked to configure ISIS as the IGP inside this AS10, and the network entity title should have that format. So for router 11, we should use this net 11.00. Then we should have as fewer databases as possible. And you may know that with ISIS, we might actually have 4 databases, one for level 1, one for level 2. So out of these 2, we can actually use only one and enable only one level, let's say level 2, because we don't need 2 levels in this topology. And then we could have a database for IPv4 and a database for IPv6. And this is how actually XR does it by default. It uses the multi-topology advertisements, and we're actually going to disable that. And maybe I should have told you from the beginning, we also have IPv6 addresses configured between these links. So if I just check this interface between 1 and 3, we have both IPv4 and IPv6 addresses configured. So right now, we understand that we should only configure one level, and that's going to be level 2. And we need to disable the multi-topology behavior, and I'm just going to write here single topology. Then we see that we need to optimize the adjacency establishment from a bandwidth perspective. What I actually meant by this is that we need to disable hello padding, because ISIS doesn't advertise the MTU value in its hello messages, and it actually tests the maximum MTU in the data plane when establishing the adjacency. By default, it pads those hello messages to the maximum MTU. So if one of the routers has a lower MTU, it won't get those hello messages and the adjacency won't go up. Then there shouldn't be any deselections on any of the links. That's simple. We need to have point-to-point links only. And then we need to configure the following metrics. And we see that on the transversal links, we need to configure a metric of 100. And this actually exceeds the maximum narrow metric, which is 63. So this means that we first need to enable wide metrics. So wide metrics enabled, and configure those metrics on links. And let's now just go through the other tasks and see if we actually need to enable something under the IGP itself. And I actually recommend you do that on the exam. And I did that. I just took 10 minutes, 15 minutes to go through all these tasks from all ASs. And I think it helped me because, as you will see actually here in this next step, we're asked to configure RSVP TE tunnels, and we actually need to enable TE for that. So why not do it when we configure ISIS from the beginning, because it's easier. We don't need to come back later to the router ISIS process to enable TE. So that's the only thing that we can take for the IGP here from this task. BGP has nothing to do with it, neither LR3VPN, NVPN no, QoS no. And this, optimize the ISIS process so that host IPv4 addresses have a higher priority when adding prefixes to the RIB. What I'm actually meaning is that we should configure a higher priority for /32 prefixes. I didn't say /32. Okay. Host IP addresses, okay. And it's actually the SPF, somehow it's called, we'll see in the command reference, it's SPF priority. When it's running SPF, it should first put these priorities in these /32 prefixes in the RIB. And what I did at the exam was, now we can close this PowerPoint presentation because we're going to need this notepad file. And what I did at the exam was to first go ahead and configure everything on one node, and then copy the configuration, replace, paste it here, replace, and just copy it to the other nodes. Just watch it how I do it. I found this method to be the most efficient one. So we go in the configuration mode and we do router ISIS. Let's call it 10 because we're in AS10. So actually let's do it in this order as I've written here. So the net is this one. We're on router 11. Then only one level. This means IS type level 2 only. Then I've said that we should only have one topology for both IPv4 and IPv6 traffic, and that's done under the IPv6 unicast address family. So here I'm just going with single topology. By default with XR we're using multi topology. With XE by default we're using single topology. So that's that. Then I want to disable hello padding, and that's done under each of these interfaces, and I'll do it later. So under the interface, and the point-to-point is again under the interface. I'll do it later. We see that we also need to configure wide metrics, to enable wide metrics, and that's done under the AF, and it's metric style wide, and the same is for IPv6. And this is done also. Configure those metrics. This is under the interface. Then enable traffic engineering. This is done under the IPv4 unicast address family. And first it's this command to enable MPLST, and then let's also configure the router ID as loopback1. So this is done also, and now we need to have to configure a higher priority for the /32, and this is actually also done under this address family IPv4 unicast, and the command starts with SPF, and it's prefix priority. So it's SPF prefix priority, and you have some preferences here. We're going to choose high because that's what the task asks for, and you can filter either by the access list or by the tag, and we're just using an access list for that. And let's just call this access list high, actually host routes. Okay, and now we're also going to configure all these interfaces. So we have two interfaces on R11, just check the topology. It's gig003 and gig004. And also we want to advertise loopback1. So let's start with loopback1. So it's headers family IPv4 unicast and headers family IPv6 unicast. And for gig003, actually, let's first configure it to disable hello padding. So hello padding disable and configure it as point-to-point. And then let's configure those metrics. So I said that these links should have a metric of 50. So all these links, the horizontal ones will have a metric of 50, and these transversal ones will have a metric of 100. So gig003 is an horizontal link, and I'll just give it its metric of 50, and for IPv6 still metric of 50, sorry. And I'll just do the same for int gig004. So hello padding disabled. Okay, disabled, and actually the point-to-point statement here, and also gig0004. I don't know why I'm experiencing this lag. IPv4 unicast metric 100, and same for the IPv6 one. And if we check the whole configuration, everything looks good. What I actually need to do is also configure this access list, which is actually a prefix list, and it's host routes, and we just want to match all prefixes with /32, and this matches everything, but it needs to be a /32. So again, this is all the configuration, and it actually looks good. So let's copy everything from here, and let's say task 1 config content, and I'll just commit this. So that's also how I did it in the exam, and now we just need to modify just a few things here. So I did router 11, I'll next do 12, then 15, then 16. And the reason for that is because 16 and 15 also have fewer interfaces, and they also have interfaces gig 003 and 004. So it's somehow an optimization. You really need to think how you can optimize everything better in the lab, because you need to be really fast. So let's start with 12, and I'm just reversing these interfaces here. So instead of 3, I'm putting 4, and instead of 4, I'm putting 3, because this is how the metrics should be configured. And that's it. That's everything we need to modify in order to apply this configuration on router 12. Let me check again. Yes, should be good. And then if we check router 15, this should have metric of 50. This gig 004 should have a metric of 100, and this gig 006 should have a metric again of 100, because it's a transversal link. And if I also modify the system IT, I'm just good to go. Okay. Hopefully I'm good, because I don't want to return to this part of the configuration. Then 16, 3 must have a metric of 100, and now I can just copy paste this. So 4 has metric of 50, 3 has a metric of 100, and 5 has a metric of 100. Okay. Then on R13, we have 1, 2, and then 5 and 6. So let me just copy this again. So 1 has a metric of 50, 2 of 100, 5 needs to have a metric of 50, and 6 should have a metric of 100, and I should modify the net, and we're good to go. Hopefully you can see it, it's not too small. And this router 13, and for 14 I will modify the net, and then just reverse these, because everything's symmetrical in service provider networks, and you should somehow feel it if you're going for the lab exam. 5, okay, this is good. 6 is good. 2 is good. 1 is good. Okay, and so this is 14, and we have just one left, and that is router. Okay, I forgot for router 13. So configure router ISIS 10 and this interface. I forgot on router 13 this interface towards this one, gig 0007, and it's 7, and it should have a metric of 100. So let me just do that on 13. Commit and end. And then here on 17, we should have a metric of 100, and it's gig 0003. Without this part. So everything should be done. Let me close these connections with the CEs because we don't need them right now. And let's start with some actual checks. So the first one is to check the ISIS process. And here we see the area ID and the metric style. So we see that we're using white for all of these. And if I just go quickly between all of these, it looks good. Then you can check this command. It's quite useful. You see that we've enabled ISIS on all these nodes. And it's router 11, 12, 13, it's 11, 12, 2 times 12 because we have two paths towards 12 anyway, 13, 14, 15, 16, and 17. So all nodes have enabled ISIS. And let's actually check the neighbors. So our 11 should have 2 neighbors, 12 again 2 neighbors, 13 should have 5 neighbors, and you can actually check just the count to make sure they're all on. 14 should have 4, this guy should have 3, and this one should also have 3, and this one just 1. We have to learn to check quite fast everything, and just looking at the neighbors count should tell you that you should be good. If I check the database, we see that we're using single topology and we're not using multi-topology. You would have seen it here with an empty before the prefix itself. And if we, what did we enable? So the links, you can tell that the links are good because we only see metrics of 150 and 50 and 100, and it looks good because we were asked to configure metrics of 50 and 100. Of course, you could go through each of these interfaces, but I don't want to do that. It's okay for me just to check on R1. And the higher priority and the MPLSTE. So let's check this priority, show ISIS route detail. And this will actually give us the priority. If we go ahead here for a random /32, we see that these have a higher priority, higher than /24, which have a low priority. And you would basically do this on all these nodes. So ISIS route detail. And this will show something similar. I'm not going to apply all these commands to all these nodes because it takes a lot, but that's how you would check that everything's fine. And before closing, let me give you a good resource for some of these features we've configured here. You can check this implementing ISIS on XR software. I'll also share this link with you. And here you can see that I've already clicked some of these links. You can check the single topology configuration and more details about what it does. I think we also have, not history, okay, Control F. We also have the hello padding in here, but yeah, why does it take me here? This is the setting priority, and I can't find hello padding, but it should be somewhere. I can't put that padding, and let's actually go up. Okay, tuning, it doesn't have its own rubric, let's say, but it has this tuning adjacencies, and you see this hello padding command here, and it says just, it doesn't say exactly what it does, but at least you see how you can configure it. Here you also see the single topology IPv6 support. It tells what it does. And then the priority and how you do it. I think you also have a configuration thing. I don't know why I keep pressing Ctrl H. You also have the configuration part for the single topology. Yeah, and it shows how it's done. So it shows the IPv6 part and the single topology under the IPv6 unicast address family. And I'm done with this ISIS part. Next, we'll continue with the MPLS part, which will be a bit longer and actually quite interesting, but we'll see it later. Now, just thanks for watching.